Skyscrapers. These towering giants are not just buildings, they are the epitome of human ambition and ingenuity. They pierce the sky, standing tall and proud, symbols of progress and innovation. They are towering symbols of human ambition, reaching for the clouds. But what makes these colossal structures possible? How do they defy gravity and stand so tall without toppling over? But have you ever stopped to wonder, how do they stand up? The answer lies in the brilliant minds of engineers and architects who design and construct these marvels. It's a blend of art and science, a dance between creativity and precision. It's all thanks to some clever engineering. From the initial blueprints to the final touches, every step is meticulously planned and executed. Engineers use advanced technology and innovative techniques to ensure these buildings are not only tall, but also safe and sustainable. We're talking about physics, maths, a bit of magic maybe. The calculations involved are mind-boggling, taking into account factors like wind resistance, weight distribution, and material strength. It's a complex puzzle that requires a deep understanding of various scientific principles. Alright, no magic, just hard work. The construction process is labor-intensive, involving countless hours of effort from skilled workers. From laying the foundation to installing the final beam, every task is crucial in bringing these skyscrapers to life. Let's dive into the world of engineering marvels. These projects are a testament to human determination and the relentless pursuit of excellence. Each skyscraper tells a story of challenges overcome and dreams realized. Big cities need big buildings, more people, less space. As urban populations grow, the demand for vertical living and working spaces increases. Skyscrapers offer a solution to the problem of limited land, allowing cities to expand upwards rather than outwards. Going up is the only way. But building a skyscraper, it's a monumental task that requires careful planning, coordination, and execution. Every phase of construction is critical, from the initial excavation to the final inspection. That's not like stacking Lego. While the concept might seem simple, the reality is far more complex. Each piece must fit perfectly, and any mistake can have serious consequences. It's a delicate balance of precision and strength. It's a whole other level. The result is a breathtaking structure that stands as a testament to human ingenuity and perseverance. These skyscrapers are more than just buildings. They are landmarks that define the skyline and inspire awe in all who see them. First things first, foundations. Imagine a giant building like a huge rock balanced on a stick. That wouldn't work very well, would it? The rock's too heavy, the stick's too thin. Same with skyscrapers. They need a strong base. That's where foundations come in. Deep, strong, spread out wide. They distribute the building's weight evenly. Think of it like snowshoes. They stop you sinking in the snow by spreading your weight. But what if the ground's rubbish? Like sand, for example. Building on sand is tricky. It's just not strong enough to hold a skyscraper's weight. So what do engineers do? They cheat. One clever trick is pile driving. Basically, they hammer long, strong pillars deep into the ground. These piles go through the weak stuff until they hit something solid. Then, the building sits on top of these piles, safe and sound. Now let's talk roads. Have you ever wondered why roads, especially highways, aren't just long, straight stretches of pavement? It might seem like the most efficient way to get from point A to point B, but there's a lot more to road design than meets the eye. Ever noticed how highways curve even on flat land? These gentle curves aren't just for aesthetic appeal, they serve a very practical purpose. Engineers design roads with curves to enhance safety and improve the driving experience. There's a good reason for that. When roads are designed, engineers take into account various factors such as the terrain, the expected speed of vehicles, and the need to keep drivers engaged and alert. And no, it's not just to keep you awake. While it's true that a monotonous, straight road can lead to driver fatigue, the primary reasons for curves are rooted in physics and safety. It's all about physics, speed, and staying safe. Straight roads are boring, but more importantly, they can be dangerous. Curves help manage the speed of vehicles and ensure that drivers can navigate the road safely. More importantly, curves help us navigate corners at speed. When a vehicle approaches a curve, the design of the road helps to guide it smoothly through the turn, reducing the risk of accidents. Imagine taking a sharp bend at 70 miles per hour in a straight line. The forces at play would make it nearly impossible to stay on the road. The curve allows the vehicle to change direction gradually, maintaining control and stability. You'd be heading for the scenery. Without curves, the centrifugal force would push the vehicle outward, potentially leading to disastrous consequences. Curves let us turn gradually, keeping the car stable and on the road. They are a crucial aspect of road design, ensuring that we can travel safely and efficiently from one place to another. So the next time you're driving on a winding road, remember that those curves are there for a reason, to keep you safe and make your journey more enjoyable. Section 5. Centrifugal force, the need for speed. Speed is an exhilarating experience, a rush that many seek whether on a racetrack or a highway. But what exactly happens when we push the limits of our vehicles? How do the laws of physics come into play when we accelerate and take those sharp turns? But there's more to it than just turning. Remember centrifugal force? This is the force that acts outward on a body moving around a center, arising from the body's inertia. It's a fundamental concept in physics that plays a crucial role in our everyday driving experiences. The force that tries to throw you out of a car when you take a corner too fast. This is why you feel pushed to the side when your car makes a sharp turn. The faster you go, the stronger this force becomes, making it harder to stay on your intended path. That force is higher the faster you go. As your speed increases, so does the centrifugal force, which can make handling your vehicle more challenging. This is why high-speed driving requires more skill and attention. So, engineers need to factor in the speed of the road when designing curves. They must consider the maximum speed at which vehicles will travel and design the road accordingly to ensure safety. This involves complex calculations and a deep understanding of physics. The faster the speed limit, the gentler the curve needs to be to keep that centrifugal force in check. Engineers design roads with these principles in mind, ensuring that the curves are not too sharp for the speeds at which vehicles will be traveling. This careful planning helps prevent accidents and keeps drivers safe. Otherwise, you'd be driving off the road. Without these considerations, high-speed driving could easily lead to dangerous situations where vehicles lose control and accidents occur. So next time you're driving on a well-designed road, remember the science and engineering that went into making your journey safe and enjoyable. Section 6. Superelevation banking for balance. To fight centrifugal force, engineers use a clever trick called superelevation. Imagine a motorbike in the wall of death. The track is angled, right? That's superelevation. They do a similar thing with roads. They bank the road slightly on curves. This helps to counteract centrifugal force, keeping your car glued to the road. Clever, eh? Section 7. Sight distance. Designing for safety. Another important factor is sight distance. Basically, how far ahead you can see on the road. The faster you're going, the further ahead you need to see. That's why curves can't be too tight. Imagine coming over a hill and suddenly there's a sharp bend, with a 10-ton lorry coming the other way. Not good. Engineers make sure curves are gentle enough so you can see far enough ahead to react. Section 8. Engineering marvels around the world. From the Burj Khalifa piercing the Dubai sky to the winding roads of the Stelvio Pass in Italy, engineering marvels are everywhere. These structures stand as testaments to human ingenuity and our ability to overcome challenges. These feats of engineering don't just look impressive, they make our lives possible. They connect us, protect us, and inspire us. Section 9. Conclusion. A testament to human ingenuity. So, next time you gaze up at a skyscraper or zoom along a winding road, take a moment to appreciate the clever engineering behind it. It's a reminder that humans are capable of amazing things. We can build tall, we can build strong, and we can even cheat physics a little bit. That's the